The area of steel I specialize in is called cold form steel. That's just sort of a technical name. It's a type of thin sheet steel that's literally cold bent, so they actually just physically bend it into shape. And while it may not look like much, it's turned out to have a huge impact on buildings in the last 50 years. So we want to understand cold form steel buildings. Of course, we can only test one building. So we got together with a group of experts and design engineers and actually professionally designed an archetype building. So the one that had all the features that we felt were of most interest for studying the entire building system. It's about a 50-foot by 20-foot by 20-foot tall or 2-story tall building. It's virtually sited in Los Angeles. And then we've actually physically constructed the building at the laboratory in Buffalo. If you're interested in earthquakes and you want to do a test on a building, then you need to replay an earthquake on a building. There's only a few places in the world or in the nation you can do that. Our project received from the National Science Foundation funding to use a laboratory in the University at Buffalo. They have a facility that allows us to take a table, which is hooked up to hydraulics. It's the same size almost as our building, so about 50 foot by 20 foot. And we can put the entire building on their table, and then we can replay in 3D the motion of any earthquake we're interested in. So we're really looking at a building that can provide the same performance we have today or better, but do it with less resources. I mean, that's what we're all asked to do every day. Do your job with less resources. That's what we're asking the buildings to do. Do the same job we've always asked you to do, but you got to have half the material you used to have. And that's what we're trying to figure out.